these quizzes when I turn them back. Right now, we are going to solve some triangles here. So, I got a triangle. Yesterday, you remember doing this kind of thing, but these were always 30s or 60s or 45s or something? Okay, if they're 30 or 60 or 45, I can do them without a calculator. But as soon as you start throwing 28s, 13s, and 52s in there, I need a calculator. Now, I want you to look carefully at this angle, and I want you to tell me about these two sides. With respect to that angle right there, this is the picture I've been given, so I'm going to use it. The angle's right there. Would you say this 10 is opposite, adjacent, or hypotenuse?
Opposite.
Opposite. So this is opposite. And would you say this X is opposite, adjacent, or hypotenuse? Hypotenuse. So in this particular picture, I'm not labeling this because there's nothing here. In this particular picture, the only two sides that are involved are the opposite and the hypotenuse. Well, what trigonometric function, sine, cosine, tangent, secant, cosecant, cotangent, uses opposite and hypotenuse? Sine. So, katoa. So the sine of 28, it's always sine angle. This is always where you put the angle. Sine 28 equals opposite over hypotenuse. Now I have an equation to solve, right? So I'm going to multiply x over here to get rid of the fraction. And then I'm going to divide by sine 28. So 10 divided by sine 28. Does that arithmetic make sense to you? Okay, I gave away my calculator, so I'm going to rely on you. 10 divided by sine 28. Just press it in. Wait a second. Go to mode. Make sure you're in degrees. Are you in degrees? Okay, then 10 divided by sine 28.
21.306.
21.306. I'll just say 0.3. Does it say? Yeah, it doesn't tell me how to round anyway. So is that good with everybody?
Yep.
Okay. Now we're going to do exactly the same thing with this triangle. So we're going to write an equation using sine, cosine, or tangent. But we need to figure out which one of them is going to be appropriate for this problem. So here's your angle. Which side is this? Adjacent. Which side is this? Hypotenuse. So now I've got a problem that uses adjacent and hypotenuse. Does everybody see that? So what function is that? Cosine. So cosine angle, the angle always goes with the cosine or the sine, whatever it is, equals the adjacent side over the hypotenuse. So I'll multiply to get rid of the fraction and then divide by cosine 13. So what happens when you divide 4 divided by cosine 13? What do you get?
4.1.
4.1? Does that sound okay to all? Everybody? All right, we'll do one more together and then I'm going to set you loose on one by yourself. All right, let's look at this one now. Be careful. This is the angle. You don't get to pick. That's the angle. So with respect to that angle, which side is this?
Opposite.
This is opposite, isn't it? Isn't this across the triangle? So this is opposite, and this is adjacent. So now we got a problem that uses opposite and adjacent. So what sine, cosine, or tangent is that? Tangent, TOA, tangent. So the tangent of 52 equals opposite over adjacent. So get rid of your fraction and type it in. This one doesn't have a division step, it's just type it in. So 5 tangent 52 is I need help, I have no idea. So 6.4?
Yep.
So our first 3 examples, we have a sine, cosine, and tangent example. Does everybody get why we picked sine for this one, cosine for this one, and tangent for this one? What does it depend totally on? Which side you've got. Yes, because when you build your fraction, it's the sides. And you gotta know what the sides are, so you know whether it's opposite and hypotenuse or whatever. All right, so let's look at D. Does anybody feel comfortable setting up an equation? I'll write it, but just tell me what to write. An equation for problem D. Your equation is always going to be either sine, cosine, or tangent. Cloud? She says sine.
No, cosine.
She says cosine.
Yeah.
Jacob, what were you going to say?
Cosine.
Cosine? Because with regard to this angle, isn't this the adjacent and that's the hypotenuse? So I might have SOHCAHTOA written on my paper just to remind myself. When I have adjacent and hypotenuse, that's cosine. When I write my equation, it's cosine angle equals x over 10, adjacent over hypotenuse. Never, ever, ever put the angle in the fraction. The angle goes with the sine, cosine, or tangent. All right, let's get rid of the fraction, so we'll times. And we're done. What's 10 cosine 17?
9.6.
9.6. Last one. Oh no, that's the one I just did. 563 in X. Now don't get confused. Look at where the angle is. Sine, cosine, or tangent? Cosine again. Because with regard to this angle, this is the adjacent side. This is the opposite one. This is the adjacent one, and that's the hypotenuse. So cosine 63 equals 5 over x. Always get rid of the fraction, and then get x by itself. So when I get rid of the fraction, I'll multiply by x, and then I'll have to divide by cosine 63. So, what's 5 divided by cosine 63? 11 point,
0.01.
so 11.0 if I'm going to the nearest 10th, yeah. Now, I'm going to be really honest with you. There really aren't times in the real world where you're walking down the street and someone hands you a triangle to solve, right? That's just made up, that's a math book thing. But these word problems are real life. These are things, maybe not with squirrels and nuts and all that, but this whole idea of trigonometry is used in real life. So let's take a look at this first word problem. The directions say draw a picture, write an equation, and solve it. So, these are exactly the same as what you just did, only you have to draw your own picture. Alright, so here we go. A squirrel is sitting in the top of a tree. Now, we're going to always assume that our tree is standing straight up and down, so that's going to be our right angle. Here's our tree. The squirrel is up here in the top of the tree. The tree is 52 feet tall. You need to stop me if I do something you're not sure about, okay? There's my tree, 52 feet tall. He is looking at a nut on the ground. So here's a nut on the ground. His angle of depression is 23 degrees. We're going to talk about that in a second. Find the distance from the nut to the base of the tree. So this is X. Nut to base of tree. Now, what's this distance? This would be nut to squirrel, which could be a question, but it's not this question. Does everybody understand this is what I'm looking for? All right, now, I gotta put the 23 in there someplace. Now, I want every beady little eye in this room looking at me right now, because this is important. And I don't want anybody messing it up. It's super simple. The 23 will never go here. You will never, ever, ever mark an angle here from a word problem. Okay? Not going to do it. Technically, the angle of depression is this. But that bothers me. Angle of depression means here I am, I'm the squirrel, and I'm looking down at the nut. So that angle is my angle of depression. But that angle, I can mark at 23, but it isn't even in my triangle, is it? But I remember from geometry that this angle and this angle are alternate interior angles and therefore congruent to each other. So I'm going to put the 23 right there. You are always going to put your angle of depression there, because the angle of depression will always match the angle of elevation. Think about if you're the nut and you're looking up at the squirrel. Isn't this your angle of elevation? These will always match. So to keep it simple, always put it right here. That's where you're going to put it every time. You'll always be right. So now my picture's drawn, and I need an equation. So what do I have to think about? Do I want sine, cosine, or tangent? Why are y'all saying tangent? You are exactly right. But why are you saying that?
Because we don't need to find.
Because this is opposite and this is adjacent. So tan angle equals opposite over adjacent, just like what we just did. So x tan 23 equals 52, and 52 divided by tan 23. The nearest hundredth, it says. So tell me what the answer is to the nearest hundredth. Huh? 40 point.
No.
I got
No.
122.
Yeah,
That's what I got
122.5.
too.
122.5. I need nearest hundredth.
Oh, but it's a zero, so it's
Oh,
five
so it's
zero.
5 0? Okay. And that would be feet. Put a unit on it. Now, whoever said 40 or whatever you said, I need you to check. 52 divided by tan
I
23.
put 52 in on the divided by and tangent 52. I had on both. For some reason.
All right. okay with that?
Yep.
Next. Now we got a seagull on the top of a lighthouse. So here's the seagull sitting on top of a lighthouse. And again, that lighthouse is standing straight up and down. Make that assumption. He spots a fish in the water below. The gull is 87 feet above sea level. So isn't this 87? He's up in the air 87 feet. The seagull is 230 feet from the fish. Where does the 230 go? On the hypotenuse. This is not anything to ever be confused about. Here's the seagull, here's the fish. They're 230 feet apart, right there. What's the question? Find the angle of depression. Remember what I was ranting and raving about earlier? You're gonna put your angle of depression there. You're gonna put your angle of elevation there. All your angles are gonna go here in these word problems. All right, well this is a little bit different, but the setup is gonna be the same. Gotta figure out if it's gonna be sine, cosine, or tangent. These are always gonna be one of those. You're either gonna have a sine, cosine, or tangent equation. So here's your angle, right here, this is your angle. I don't know what it is, but that's where it is. So which sides do I have? Opposite and hypotenuse. So the equation I write is going to be a sine equation. Now remember, it's always sine angle. So in this case, it's sine x equals 87 over 230, opposite over hypotenuse. This is different. This is different. When your angle is the x, we need a special button on our calculator. When the angle is the x, you are going to use this button. Have you seen that button and wondered what it was for?
Yeah.
That button and the other ones. So this one, and this one. These are the buttons that find angles. So these are the buttons that you are going to use every time x is the angle. So again, I don't have a calculator, so I'm going to count on you. You're going to type second sine, that's how you get this, right? Second sine, 87 divided by 230.
22.23.
22.23 degrees. Everybody get that? Now, kids, we need to be real clear. On this problem, I used regular tangent because I knew my angle. I only do the special tangent when I'm looking for the angle. So you gotta remember that. These are the buttons if you're looking for the angle. Isn't this fun? Yeah, it is. All right, next. How far is an airplane from the airport if he is currently 5,000 feet above the ground and the pilot's angle of depression to the airport is 17 degrees? So here's my airplane, and here's my airport. The plane wants to come in for landing here. The plane is 5,000 feet above the ground. Does that make sense? His angle of depression is 17 degrees. I'm not confused about that. I always put my angle there. How far is the plane from the port. Now again, don't overthink it. Don't make it confusing. Where's the airplane? Where's the airport? So if I want to know how far apart my fingers are, isn't that this? So I'm going to write an equation. Sine, cosine, or tangent. Sine. And it's always sine angle. It's sine, guys, because this is opposite and this is hypotenuse. So sine angle equals 5,000 over x. So I'll multiply by x and divide by sine 17. Sine 17 is a unit, guys. They go together. So you don't divide by 17 and you don't divide by sine. You divide by sine 17. That's going to be quite a large number.
17,101.
17,101.52, and that would be feet, I believe.
Yeah.
Find the height of a flagpole. So here's my flagpole. X is its height. The shadow is 13 feet long. Okay, now where am I going to put the 13? Eli says right here. Because again, guys, where is the shadow? On the ground, right? And the angle of elevation is 59 degrees. Need an equation, sine, cosine, or tangent. Tangent. Everybody got that? Opposite, adjacent. So tan 59, always put the angle with the function. So tan 59 equals opposite over adjacent. I'll multiply, I'll always get rid of your fractions, so 13 tan 59. And the x is already by itself, so I just type it in.
21.64.
21.64, and I believe that's feet.
Yep.
You guys are doing amazing. We're gonna do one more problem and then I'm gonna stop, okay? One more, last one. I'm gonna be done with 4-2. All right? So Grant, hang with me, we got one more to go. You had a rough week, Grant, not sure what's going on there.
That's not true.
You seem kind of tired and bored.
A little bit. I don't know. Get it back into it.
All right. What is the angle of elevation of a man looking at the top of a building? So here's my building. And there's a man out here, somewhere here's the man. And he's looking up at the top of the building. This is the top of the building. The building is 48 feet tall. And the man is standing 100 feet from the building. Where do I put the 100? On the bottom. It's common sense. Here's the building, right? It's like if I said, how far am I from that wall? Wouldn't I measure on the floor? That's what we're doing. Now, what's the X?
The angle.
The angle. Uh-oh. That means after I get my equation set up, I'm gonna have to be doing one of my specials. Second sine, second cosine, second tangent. All right, so what's my equation going to be? Tan X
equals 48 over
equals opposite over adjacent, 48 over 100. Then to get X by itself, I have to do second tangent, 48 over 100. that should give me an angle of,
25.64.
what is it,
25.64.
25.64?
Load again.
Everybody,
Not that
is
sure.
25 the right answer? 25.64? All right, I'm gonna be done for the day. I wanna remind you of two really important things. First of all, every equation you write is gonna be sine, cosine, or tangent. How do you know which one to use? Well, which sides you have, right? SOHCAHTOA and which sides you have. And then, when do we do this fancy stuff right here? When the angle is the x, okay? When the angle is the x, you immediately go to the